Hello everyone and welcome to the fifth episode of CPSP Next. Today we will continue exploring reinterpret misbehavior. We will talk about one of the things probably most of us use and never thought it is undefined behavior. So let's start with an example. So what do we have here? We have a struct with two arrays inside it, A and B, which is integers and floats. Then let's say we're processing some data that we're receiving from the network. We're receiving with an array of bytes. And then what we're doing is we're using reinterpret to cast the char buffer into a data pointer. And that's fine because we can cast anything from chars to anything. And then we're using std_loader that tells the compiler, hey, compiler, this is not anything else. This is actual data. Please use it as data, which is fine as well, as we learned from the previous episode. Then we're just using it and assigning to the arrays. So if everything is fine, why is it still considered being undefined behavior? The problem is that the data object lifetime was never started. That means it doesn't exist. And because data object doesn't exist, it means it's undefined behavior. Most compilers are nice enough to allow this and not to create something that will cause problems. And that's why most of the programs that use this pattern actually work. But we shouldn't forget that this is undefined behavior and this is compiler independent implementation defined. So each compiler can do whatever it wants here, and that's a problem. How can we fix that, you ask yourself? Let's look at the next example. Here, as you can see, we are starting the object lifetime because we are creating a new D that is assigned with default values. Then we are copying the content that we receive from the network into D. Then we are using D, and then we are copying back. In this case, everything is fine. We created a lifetime. There is no undefined behavior here. You might ask yourself, but what about performance? Let's look at the assembly for x86. As you can see, the compiler is smart enough to understand the pattern. It understands that all that we wanted is just to start the lifetime of the object, and then it optimizes out all things that have to do with std_mem_copy. That means we have a safer program without undefined behavior, and our performance was not compromised. But in some specific cases, this pattern might not be recognized, and that's where C++20 has the upper hand. In C++20 we got enhanced memcopy and memmove functions. Those functions now start the lifetime of an object, and that means we can create a different pattern without copying that will enhance our programs to be safer and have the same performance. Let's look how to implement it. What have we done here? We have used memmove to move from buff to buff. That means we are moving to the same memory address. That means that we are not doing anything with it. We are just saying, please initiate the lifetime of this object. Then we are reinterpret it to data. Then we are using Launder to tell the compiler it's 100% data pointer, not anything else, fully defined behavior, and then we are using it. And as you can see, it's simpler. And if we will look at the assembly, we will see that the assembly understands that it is just usage of the pointer, and that's it. Now, with C++23, things can get even simpler. We got new functions called startLifetimeAs and startLifetimeAs an array. Those functions do almost exactly the same thing as I illustrated in the previous example. But this function will look at more edge cases. The problem with those functions is that there is still no compiler support for them. So now, when we fully understand the implication of these usages that most of us use almost every day, we understand that it's very important not to be here. And I hope you understand that you have options to create fully defined programs without problems and not getting hit with performance. Please use Safer C++. In any case, I will be giving a keynote in CPP India in a few weeks. Hope to see you all there. And as always, like and subscribe. Thank you and see you in the next episodes.